Hello and welcome to BioRules Video Lessons. Today we are going to be talking about biodiversity, or how biologically diverse, varied, with differences, is an environment. So to illustrate that, I have here three communities, and I ask you, which of these three communities looks to you as more biodiverse? Which community of this here seems to you to have a higher biological diversity, taking into consideration that each color represents one different species? So is it the left one, is it the middle one, or is it the right one? Which one has the biggest biodiversity? Take your time. If you need, pause the video and then carry on. Okay? First thing, what we can do here very easily is to count how many species are there. So those are the species that are present in the left environment. Those are the species that are present in the middle one, and those are the species that are present in the right one. So actually, I don't know if you've said that the right one was more biodiverse, because most people look at this and they answer, oh, the right one is more biodiverse. Okay, usually that's the answer. However, the left one that people usually say this is the least biodiverse, looks almost all green, has more species. So this one has 8 species, the middle one has 6 species, and the right one has 4 species. The number of species, we call it richness. So richness is a factor that should be considered when you talk about biodiversity. Usually environments that have more species tend to be more biodiverse, but that's not necessarily a rule. As you see here, it looks like the right one is more colorful, so it shows that you have more variation, while the left one, although it has 8 different species, it looks like you have a dominance of the green. It looks almost all green, right? So richness, total number of species in an environment. It can be useful, but does not necessarily imply that you're going to have a big biodiversity. So what is biodiversity? Let's get the same 3 boxes as examples, and let me show you how we can estimate the actual biodiversity. In this case here, we will estimate how colorful one of these boxes is in comparison to the other. This rule for biodiversity is calculated using a formula that you need to learn called Simpson Diversity Index. Basically, D for diversity equals the total number of individuals in a place, big N, times the total number of individuals in a place, minus 1, divided by the sum of each species' total number of individuals, multiplied by that number minus 1. So for that, then we need to know how many individuals are there. In the left box here, we have 83 balls. 69 are green, 2 are that purple, 2, we have 2 of all the other ones. Okay, this is the numbers that we have. In the middle ones, we have 40 individuals, but you have 25 of the green, and you have 3 of the other ones. And in the right one, actually, we have 60 individuals, but we have only 15 of each. So yes, it looks like it's more even. But how do we transform that into a number? We use the formula above. If you already got the idea of the formula, now it's time for you to pause the video and calculate, so then you can compare to my result I'm going to show you. If you didn't get the idea yet, don't worry. Next example, I am going to be showing you. Okay? Okay, now that you unpause the video, if you did the calculation, you probably found something related to this. In the left one, the D was 1.45. The middle one, 2.47, and the right one, 4.21. This is showing us what? That the biggest biodiversity is going to be found in biggest numbers. So the biggest biodiversity is bigger this number is. So 4.21 is a big biodiversity. 1.45 is a small biodiversity. Okay, this number tells us to compare biodiversity in 2 different environments that should be quite similar, but in this case here we see that clearly it's not. Okay, so if you did the calculation, you got it right, well done. If you didn't, let's work on one example here together. So I'm putting here some species that were found in island number 1: clover, daisy, roses, and violets for flowers. Okay, this here we are going to be using the formula that I showed before, the Simpson Diversity Index, and we need the total 1,571. So how do we apply that formula? If you already know how to do this, pause your video, work out, get the number, and then check out to see if your number matches with my number. Okay, so if you have your number already, or if you're going to be following me, how do we do this? The big N is the total number of individuals in a place. So this here is 1,571. Basically, it's when we added those 4 species totals together. Okay, that's the easy part. 1,571 times 1,570. Okay, what about the other, the sum? The sum of each species. So we are going to be getting here 537 for clover times 536. Then you get 402 for daisy times 401. 293, sorry, for roses, 200 times 292, and 339 times 338 for the violets. When I did that, I'm going to be finding a number on the numerator, one in the denominator, and I calculate that using a calculator, and I will find here that diversity for island number 1 is 3.79. If you find the same number as me, well done, you got the idea how to do. If you didn't, let's check your calculation. If you are following me, so now is the time for you to calculate it for island number 2. So island number 2, we have clover, daisies, roses, violet, and the total. Those are the numbers. And now I ask you to pause the video and try to calculate it by yourself. Okay, probably now you have your value, so I will show you here how I calculated. So the total, 1309 times 1308. This is the overall total. And then I will do the same for each species doing the sum. So 1191 times 1190 for the clover, 52 times 51 for the daisy, 47 times 46 for the rose, and 19 times 18 for the violets. When you put all that into the calculator, we are going to find a value D for diversity equals 120. That's the Simpson diversity number here. What does it mean? It means that biodiversity is bigger here and it's smaller here. We have similar islands, similar place, same species around, clover, daisies, rose, violets, but you have a different evenness of those species. Although both of them have the same richness, have 4 species in each, you have a much more concentrated number here in the number of clovers and much smaller number here of the others. So basically in island number 1, most plants are clovers. In island number 2, most plants are clovers. While in island number 1, the numbers are more even. If you look around, you're going to have clovers and daisies and roses and violets. So this is what the diversity means. Okay? So D indicates how even it is. Actually, it indicates the evenness of a certain place. One more example. So let's work on one more example. I have here some animals that live in rivers. So I have a list of species found in rivers, and I'm going to be having 2 different rivers in here. River number 1 and river number 2. And the number of individuals found for each species in there, they have some species that are different. So river number 2 don't have the Biopecularis, the A. norberti, the Simiersi, okay, but has other species that the river number 1 doesn't have. And they have some in common. Okay, so now the question is, calculate the Simpson Diversity Index for each of these 2 rivers. So you want to know if of these 2 rivers is more biodiverse. Now take your time, do the calculation, pause the video, and then you continue when you have the figures. If you did your calculation like I did it right now, and I hope I got it right, please tell me if I did wrong, I found 1.75 for river number 1, and I found 6.651 to river number 2. So those are the values. If you got the same value as me, I rounded to 2 decimal places. Please let me know. If you found a difference, please let me know, so I check out to see if I screwed up in my calculations here. Okay. The question then is, what these numbers indicate? What does it mean? So what these numbers indicating that river number 1 has a smaller evenness, so has few species dominating the entire place. We see here that we have 771 of L. curviceps, and we have few of the others, while we have quite a few, 150 of G. altifrons, but all the others are less than 100. And here we have, look, more than 100, almost 100, more than 100, more than 100, more than 100, almost 100. So we have a more even distribution of species. Okay, so what does it mean? Okay, what is causing this? So those are 2 rivers that have similar species. What may be causing it? Maybe for 1 species or 2 species here to be dominating, this river with a smaller biodiversity probably have conditions that are tough for other species to live in. While river number 2 apparently have conditions that are more nicer for the animals to be living in. So maybe river number 1 has pollution. Maybe river number 1 has a high level of chemicals that are lowering the oxygen in the water. So there is something there that is making river number 1 to have a different richness, not richness, actually, a different evenness, diversity than river 1 and river 2. So river number 2, more biodiverse, probably a more stable, more preserved river. Okay? If you are still having problems with the calculation, please check it out how to do it, exercise, give it a try. You need to be able to calculate it by yourself. Use and remembering the formula. You need to remember the formula as well. Okay? So now let's talk about biodiversity, why to preserve it. And at this point here, I'm talking about huge environments with that have big biodiversity. And in some situations, like we are going to be using from now on, biodiverse sometimes is used to refer as a high richness or to refer as a high evenness. For example, Brazil is the country in the planet with the biggest biodiversity. Actually, they didn't count the number of individuals for every single species in Brazil to calculate the evenness. What we know is the number of species that we have in Brazil. So we have more species in Brazil than we have in Indonesia, the second place with the biggest richness in the planet. But people say Brazil has the biggest biodiversity because usually big number of species means big number of evenness or whatever. So sometimes they are going to be used one or the other, but be aware that they are not synonyms. Biodiversity means evenness. Richness is the number of species. In some situations right now, we may use them together. Okay? So question, why to preserve high biodiversity? So I'll take a rainforest as an example. Tropical rainforests have a very high richness of species. Also has an evenness, a good evenness, but has a very big richness of species. Why should we preserve them? So there's a tropical rainforest. There's a picture I took from the window of my house when I lived in the mountains of Espírito Santo. Okay? So tropical rainforests have a huge number of species. Many species. A lot of species. So to have an idea, a tiny little forest like Serra do Japi, here close to São Paulo, no, it's smaller than the area of the city of São Paulo, has more butterfly species than the entire North America. So usually tropical rainforests, they have a huge number of species. Okay? All those species, they have the right to live. So one argument for us to discuss why preserve biodiversity is because every single species that are there have the right for existence. Okay? Also, when you preserve biodiversity, you are preserving food webs. You're preserving these organs that eats that organ, that eats that other one. So you keep the equilibrium in an environment, and that's quite important. Okay? Biodiversity, or richness at least, may mean also commodities. There are species out there that may have compounds that we can use to treat diseases. Who knows, maybe the cure for cancer is somewhere there in the Atlantic rainforest or in Amazon or in Indonesia. Okay, there are some species that have genes and produce things that can be used for food. For example, a few years ago, they found a wild tomato that was very, very, very sweet. This wild tomato was very small, not very good for agriculture, but the genes that made them sweet could be transferred for the regular tomato to make tomatoes sweeter. And sweeter tomatoes are more nutritive and are more easily and cheaply transformed into tomato sauce. So it was something that was in one wild tomato there in Mexico that suddenly revolutionized the tomato food industry. So commodities are something that we should preserve because tropical rainforest or any place that have species, one of those may be the answer for a problem that we have as humanity. Another reason is to preserve because of ecotourism. People like to visit places of high biodiversity. We like to visit nature. And this here as well help the natives, not only the indigenous populations, but the people that live in that place. For example, the people that live in Petar, Parque Estadual Turístico do Alto Ribeiro, where we have the caves, massive, very, very big tropical rainforest there. People like visiting there. That moves a very powerful ecotourism industry that feed all that people over there. Okay? And so ecotourism and the tropical diversity as well, and using the products from a forest in a sustainable way, they can be very good for local economy. Apart from that, forests especially, they are very important to control microclimate. Plants, they can have an area in leaves that are more than 10 times the area of the soil that they cover with those leaves. That means that they will transpire 10 or more times than the soil without the forest. And transpiration will cause clouds that will cause rain. If you cut down the trees, you're going to change the microclimate, and actually you may change a fairly global climate. For example, the southeast of Brazil is getting drier, less rain, because of the reduction of the area of forest in the north of Brazil, in Amazon. Because our rain here, our humidity here, comes from the transpiration north of Brazil. So you cut the forest, we have less rain here in the southeast. Additionally, forests, they protect the soil from erosion. You cut the forest, the soil gets exposed, and it's usually washed up by the rain, so it gets poor and not very good to use for agriculture or other purpose. And then you're going to be needing to add fertilizer and stuff, so not a very good idea to cut them down. And finally, one argument that I've seen in exams that was a mark: aesthetics. Forests, tropical rainforests, are beautiful. Many artists get inspired by them, painting and drawing and writing songs. So, for the aesthetics purpose, just for the sake of being pretty, it should be preserved. Okay? So, I hope you had a good time, that you learned a lot about biodiversity. Please exercise with the formula calculating Simpson Diversity Index for some environments. You will need to do this later. I hope you had fun.